Hey everybody, we've talked about lines and the slopes of lines. Some of us still have some questions when it comes to computing the slopes of lines. So let's go over the basics and let's do some examples involving slope. First of all, let's remember what it is that the slope of a line is. How do we define the slope of a line? First of all, we denote the slope with the letter M. When we're talking about lines and we use M, we're talking about the slope. And just in terms of common sense language, the slope measures the change in the y value divided by the change in the x value as we go from one point to another on the line. So if we pick two distinct points on the line and we go from one point to the other point, the slope measures the change in the y coordinate divided by the change in the x coordinate. Again, as we go from one point to another point on the line, the slope M measures the change in the y coordinate divided by the change in the x coordinate. So let's be more specific. How do we compute this? To compute the slope, generally speaking, we have to pick two distinct points on the line. And we'll call the first point x1, y1. And we'll call the second point x2, y2. x1 and y1 are the coordinates of the first point that we picked. x2 and y2 are the coordinates of the second point that we picked. And you remember just a second ago, we observed that the slope measures the change in the y coordinate divided by the change in the x coordinate. Well, here, the y coordinate changes from y1 to y2. So y1 and y2 are going to give us the change in the y coordinate as we move from this point to this point along the graph. And what about the change in the x coordinate? As we move from this point to this point on the graph, the x coordinate changes from x1 to x2. So we use these two values, x1 and x2, to get the change in the x coordinate. And let's give the formula now. Slope we denote that by m. The slope m equals the change in the y-coordinate. Well, we went from y1 to y2. So we take the place where we end up, y2, and subtract the place that we started from, y1. Change in y is y2 minus y1. And change in x, we started at x1, we ended up at x2. So we take the place that we ended up and we subtract the place that we started from. Change in x, x2 minus x1. x2 minus x1 is the change in x y2 minus y1, that's the change in y. And I want to mention something else because we might be thinking, well how do we know what points to pick? And the answer is, it doesn't matter. Any two distinct points will work. And let me emphasize that. You see that? This value, the slope, doesn't change depending on our choice of points. If we have a line and we pick any two distinct points on that line and compute the slope, and then take any other pair of points on the line and compute the slope, we're going to get exactly the same thing. So any two points on the line will work. And regardless of which 2 points we pick, we're gonna get the same answer. So let's do some examples. Here's a good one to start off with. Compute the slope of the line that contains the points 5, 3, and 3, 5. So we have a line that contains these 2 points. And they want us to compute the slope. We're going to use the slope formula. That's something that we should memorize, by the way. Here's our slope formula. M equals y2 minus y1 over x2 minus x1. And here's some clarifying information. x1 and x2 are 2 distinct points. On the line. Okay. In our example, we have 2 distinct points on the line. So it looks like we have all the information that we need. I'll tell you what. Since this point appears first, let this be the first point. And that will mean that 5 is x1 and 3 is y1. This will be our second point, and that will mean that 3 is x2 and 5 is y2. And we just take these values and plug them in to that formula. Y2 is 5. Y1 is 3. Now we do x2 and x1. x2 is 3. And x1 is 5. There we have it. Y2 minus y1 over x2 minus x1. And that's going to give us 2 over negative 2, which simplifies out to be negative 1. Now, we're done, but let's address some concerns that we might have. Very arbitrarily, I just decided that this was going to be the first point, x1, y1. And this was going to be the second point, x2, y2. Suppose that for whatever reason, I just decided that this was going to be the first point, and this was going to be the second point. What happens then? Suppose this is the first point, and 3 is x1, and 5 is y1, and this is the second point. 5 is x2, and 3 is y2. Well, I made this my first point, and that my second point. Isn't that going to change the answer? Let's see. Let's do it again. Using our reassigned values of x1, y1, x2, y2. We still use the same slope formula, y2 minus y1 over x2 minus x1. Y2, that's 3. Y1, that's 5. And now x2, that's 5. And x1, that's 3. There we have it, y2 minus y1 over x2 minus x1 with our new values. And we'll get negative 2 over positive 2. Son of a gun! We get the same answer either way. So if we have 2 points on a line, how do we know which one to call x1, y1, and which point to call x2, y2? It doesn't matter. We just pick one point and call it x1, y1. Call the other point x2, y2, and then stay with that convention throughout the exercise. Once we've assigned values of x1, y1, and x2, y2, we keep those values. We don't switch in the middle of an exercise. Now let's see what else we can do with the slope. Okay, everybody, let's sink our teeth into this one. Same kind of exercise, different points. Compute the slope of the line that contains the points 1, 3, and 4, 9. And just arbitrarily, we'll pick one point and call it the first point. Might as well be this one, right? Call this one x1, y1. That's our first point. And call this one x2, y2. That's our second point. And then we just use the slope formula, y2 minus y1 over x2 minus x1. And we need y2, which is 9, minus y1, which is 3. And on the bottom, we need x2, which is 4. And x1, which is 1. Okay. There we go. 9 minus 3 is 6. 4 minus 1 is 3. And our slope m is 2. Let's do one or two more of these. We'll do some special cases of this. Here's a good one. Compute the slope of the line that contains these two distinct points. We're going to use our slope formula, y2 minus y1 over x2 minus x1. And again, we might as well just let this one be the first point, x1, y1. Let this be the second point, x2, y2. And let's compute. Y2, that's 5. Y1, that's 5 also. X2, that's 1. And X1, that's 2. Y2 minus Y1 over X2 minus X1. And we get 0 over negative 1. 0 divided by anything other than 0. 0 divided by any other number is just 0. Huh. Is this legal? Is it legitimate? From the other videos, you might remember that it is. If the slope of a line is 0, what that means is it's a horizontal line. A line that has positive slope goes uphill from left to right. A line that has negative slope goes downhill from left to right. And what's in between positive and negative? 0, right? A line with slope 0, it doesn't go up, it doesn't go down, it just keeps going from left to right horizontally. The slope is 0. It's a horizontal line. Every point on the line is 5, including the Y-intercept. Now, we'll worry about those details in future exercises. Next example. Compute the slope of the line that contains these 2 points. And arbitrarily, we'll let this be the first point. Call this x1 and y1. We'll let this be the second point. Call it x2, y2. And we use our good old slope formula. Y2 minus y1. Y2 minus y1, that's 1 minus 2. Now x2 minus x1. x2, x1, 5 minus 5. We get negative 1 over 0. Now there's a big difference between the last example and this example. The last example, we had 0 divided by a non-zero number. Here we have a non-zero number divided by 0. And dividing by 0 is something that we don't ever do. There are some things in life that we don't ever do, such as taking an unloaded gun and putting it to our head and pulling the trigger, because it might not be unloaded after all. We don't ever do that. Another thing that we don't ever do in life is divide by 0. And so when we have a situation where division by 0 occurs, we can't give this expression a numerical value. If we divide by 0, we have to say, can't do that, undefined. So that's our answer. And let's just milk this a little bit more. When we have a line that has an undefined slope, what does it look like? That's right, vertical line. It's a vertical line, and it goes through the x-coordinate 5 on the x-axis. Okay? New kind of example coming up. Next, we want to remind ourselves of the slope-intercept form of the equation of a line. And this is it. This is the slope-intercept form of the equation of a line. And I'll tell you something. Every point xy that's on the line satisfies this equation. We plug x and y in here. This equation is going to be true. So every point that's on the line, every point xy that's on the line satisfies this equation. And it goes the other way too. Every point xy that satisfies the equation is also on the line. So if we pick a point xy and plug it in here and it makes the equation work, that point is on the line. Now, this is called the slope-intercept form of the equation of a line. And I guess there has to be a good reason. M is the Y-intercept. No, it's not. Excuse me, must have been all those drugs I did when I was a kid. M is the slope. And this guy here, this is the Y-intercept. So the number that multiplies x, the coefficient of x, that's the slope. And this number that we add on to the end, that's the Y-intercept. Before we do any graphing, let's just do a couple of quick examples to help us get familiar with this form. Let's do this one, just a warm-up exercise. The equation y equals 2x plus 6 is the equation of a line. Find the slope and the Y-intercept. Okay, to do this, we'll go back to what we know. Let's say the slope-intercept form. The slope-intercept form of the equation of a line is y equals mx plus b. And m represents the slope. And b represents y-intercept. Well, this is in the same form, isn't it? Y equals something times x plus something. Y equals something times x plus something. Slope-intercept form. So the multiplier or the coefficient of x is m. And the y-intercept, this thing, is b. So the slope m is 2. The y-intercept, b, is 6. And that's all there is to it. Let's do one or two more like this. Another example. The equation y equals negative 3x plus 4 is the equation of a line. Find the slope and the y-intercept. Okay, well, notice something. This is in the form of y equals something times x plus something. So here's our m, and here's our b. So m is negative 3, that's our slope. And the y-intercept, b, is equal to 4. Now let's change this just a little bit. Slight twist. Yeah, this one has a little twist to it. The equation 8x equals 2y plus 10 is the equation of a line. Find the slope and the y-intercept. Well, the first thing that we recognize about this is that it's not in slope-intercept form. slope-intercept form. That's y equals mx plus b. This is not in that form at all. So what we're going to do, we're going to take our equation and step by step we're going to get it in this form. The first thing I think we need to do is get our y on the left side. So we'll subtract 2y from both sides. 8x minus 2y is 10. We just subtracted 2y from both sides. Next, I think we need to get x on the right. In the slope-intercept form, x is on the right. So we'll take this 8x and move it over to the right. We'll subtract 8x from both sides. And we're getting closer. This is what we want. This is where we are. We got y on the left, and we got x and the constant on the right. The last thing that I think we need to take care of is that to get it in this form, the coefficient of y has to be 1. We don't want some number times y, we just want y. So to get rid of this -2, we're going to divide both sides by -2. Whoops. We're going to divide both sides by -2. And the -2's cancel here. We get y. That looks good. -8 divided by -2 is 4. And 10 divided by -2 is -5. Slope-intercept form. This equation is in exactly the same form as that equation. So the multiplier of x is our m. And the constant out here is our b, our y-intercept. Excellent, excellent, excellent. Now I'm going to give a different kind of example. This is a pretty good one. A line has slope 3 and y-intercept equal to -2. Give the slope-intercept form of the equation of a line. Remember what the slope-intercept form of an equation of a line is? Y equals mx plus b. M is the slope. And b, that's the y-intercept. Well, we know what the slope is, don't we? Slope is 3, so that's m. The y-intercept equal to -2, that's b. Y equals m. which is 3x plus b. b is negative 2. So if we add a negative 2, that's just like subtracting. If we add a negative 2, that's just like subtracting 2. So now we have it in slope-intercept form. Here's a good one. Graph the equation y equals 3x plus 1 using the slope and y-intercept. Okay, that's good. Before we do this, though, I want to mention something that will be helpful in doing all exercises of this type. It's a convention that we want to adopt. And I'm going to draw a picture of the XY coordinate system. Here's the x-axis. Here's the y-axis. And as a convention, I'm going to establish that if we move from left to right, that's the positive x direction. And this is a convention that's universal. When we're looking at the XY coordinate system, if we move from left to right, we're moving in the positive x direction. Now let's also adopt a second convention, and this is also a universal convention. If we move vertically, going upward, this is the positive y direction. So moving upward vertically is the positive y direction. Moving from left to right, the same way that we read, moving left to right is the positive x direction. Okay. Well, what happens if instead of moving from left to right, I move from right to left? This is the negative x direction. And suppose instead of going upward vertically, we go down. Instead of going from bottom to top, we go top to bottom. What about that? This is the negative y direction. It's very important for us to realize that these are conventions that we're establishing right now. They're universal conventions in the world of math. And these conventions are going to remain the same. They're not going to change ever. If we go from left to right, that's the positive x direction. If we go from bottom to top, that's the positive y direction. But if we go from right to left, that's the negative x direction. And if we go from top to bottom, that's the negative y direction. These conventions are going to be very important for us when we do exercises like this. And speaking of exercises like this, let's do this exercise. This is in Slope-Intercept Form. M is the slope, so M equals 3. And B equals 1, that's the Y-intercept. And we're going to graph the equation, so I guess I had better put the XY coordinate system up there. Okay, I think I got my act together now. We have the XY coordinate system plotted. And we have an equation in slope-intercept form. First thing we do is just plot the Y-intercept. We have one point on the graph. To draw or to graph that line, all we need is one other point on the line. And we can find that using the slope. The slope is 3. And that equals change in Y over change in X we already have one point on the graph. This is the point 1, 0. That's the Y-intercept. X is always 0 at the Y-intercept. So we'll let this be, you know what? I don't like the way I'm doing this. There's nothing wrong with it. Nothing wrong with it. But I think I can do it better. This is the slope. And the slope is the change in the Y coordinate over the change in the X coordinate. And we can make these two things anything we want them to be as long as change in Y divided by change in X is 3. So why don't I just do what's easy and make the change in Y 3 and the change in X 1. 3 over 1 is 3, isn't it? Change in Y, we'll have that be 3. Change in X, that will be 1. Change in X 1, that means we go 1 unit in the positive X direction, left to right. So here we go, 1 unit in the positive X direction. Change in Y, that's positive 3. We go 3 units in the positive Y direction. 1, 2, 3. 3 units in the positive Y direction. And that gives us another point on the line. This point right here. So change in Y was positive 3 units. Change in X was 1 unit. This gives us our second point on the line. And now we just connect those 2 points. And here's our second point. x equal 1, y equal 4. Now let's revisit this and do it in a similar way, but let's just see what we could have done differently. Same exercise. We're going to graph the equation y equals 3x plus 1. And the first thing we do is plot the y-intercept. Here it is, y equal 1. And this is the point, y equals 0, x equal 1. No, I didn't say that the way I wanted. This is the point x equals 0, y equal 1. There we go. Okay. The slope is 3, which is the change in y over the change in x. Could we do this? Could we let the change in x be 2? And then whatever goes up here has to be such that this thing divided by that thing is 3. Let's say the change in x is 2. And whatever goes here for the change in y has to be such that the change in y divided by the change in x is 3. So what should that be? 6? 6 over 2, that's 3. Change in y is 6. Change in x is 2. We can do that. And the change in x is going to go from x equals 0 to x equal 2. So change in x is 2. And the change in y, oh my goodness, it's going to be 6. It's going to go from 1, and it's going to go up 6 units in the positive direction. 6 units. So we end up at the point 2, 7. Now let's see, does that work? We start at this point, 0, 1. And why don't I just write it here? 0, 1. And we go to this point, 2, 7. The change in x is 2. It goes from 0 to 2. The change in y goes from 1 to 7. The change in y is 6. So we have a second point for our line, and we connect those 2 points. And there's our line. And you know what? We're going to get the same line that we had before. Check it out. The point x equal 1, y equal 4 is on this line. So this method gave us the same line that we got using change in x equal 1 and change in y equal 3. Now let's do another completely different example. This one's kind of nice. Graph the equation y equals negative 2x plus 5 using the slope and y-intercept. Well, we know the drill. Identify the slope. That's m. Y-intercept, b is 5. And the first thing that we're going to do is plot the y-intercept. Here it is. It's at 5 on the y-axis, or more correctly, it's the 0.05. We've got one point on the line. All we need is another point. We're going to use the slope. The slope is equal to change in y over change in x. And notice this. Suppose that we just change x from 0 to 1. X is 0, and we go in the positive direction 1 unit. Since we're moving from left to right, that's in the positive direction. What would the change in y have to be? So, whoops. Let me stick something else here. Change in y over change in x. Slope is -2. Change in y over change in x. And we decided somewhat arbitrarily to make the change in x 1 unit. We're going to start at x equals 0 and go 1 unit to the right. What does the change in y have to be so that the change in y over the change in x is -2? Doesn't the change of y have to be -2? Well, how do we draw a change in the y-coordinate of -2? Well, remember, vertically, the negative direction goes from top to bottom, going down. So if we go a -2 units in the y direction, we're going down like this. 1, 2. Over 1 unit in the positive x direction, down 2 units in the y direction, down 2 units in the negative y direction. And we have our second point. So we went -2 units from top to bottom. We have our 2 points. Let's connect the son of a gun. Now, just like we did the other example twice, let's do this one again. We still have the same equation. And the y-intercept is 5. We plotted the y-intercept. And now we're going to move in such a way that as we go away from this point, the change in y over the change in x is -2. So suppose this time, just arbitrarily, I change x by 2 units, +2 units. So we start here at x equals 0, and we go +2 units from left to right. And then we have to move a certain number of units in the y direction, so the change of y over 2 is equal to negative 2. Our change in y, what we put up here, has to be such that this thing divided by 2 is negative 2. What divided by 2 is negative 2? Negative 4? Does that work? Negative 4 divided by 2 is negative 2. Yeah, that works. We've gone 2 units in the positive x direction, left to right. Now we're going to go 4 units in the negative y direction. So we're going down 4 units. And let's see what that looks like. We're going down 4 units. Or negative 4 units in the y direction. And that gives us our second point. Here's our line. And notice something. When x is 1, y is 3, this is the second point that we used the first time we did this. So it gives us the same line that we get if we use a change in x of 2. Okay, everybody, let's get to work.